Okay, we're recording. Okay. All right, this is Durwood King with ELC 117 Motors and Controls. And this is January 19, Tuesday. And we're going to continue where we were on single phase motors in chapter 1. And we're going to do some hands-on with that. And I'm going to do my best to remember to move this camera to where we are. I hope we can keep this camera on track. So anyway, let's go back to the screen. Now, any questions about hooking this motor up on low voltage, which would be 115, or 230, which would be the high voltage? Any questions on how to do that? Because we're going to do that now.
So I got the diagram. No.
Right. Okay, so the game plan is this. This motor here, this one is set up for 120 volt, 115, 120. So you're going to go through, I'm going to give you a lab sheet that has 4 blanks on there. For single phase motor, everybody in here individually got the wire one single phase low voltage and see it run. And then flip it and make it go in reverse and see it run. And also do another motor that's like that, but do it on the high voltage on the 230. And the 230 is out here. We're going to roll this one out there and roll this out there and hook up. I've got a little 230 disconnect here that we're just going to use a manual switch to do it with out here. And the power's out there. And we need to tie in a cord coming in, the cord leaving, because I didn't have this set up. So anyway, this is going to be our disconnect. We've got the thing. I'm going to let you tie the cord coming in and the one leaving going to the motor. We'll take one of those motors. We'll bolt it down to the table out here, bolt it down. And we'll have us a quick little thing, kind of like we do over here with this one. This one has got a switch. Right on this side, a manual starter. It's just a heavy duty switch for a manual starter. So,
Does the camera need to see it?
Yeah, we're going to roll it out there. We're going to roll it out there. Yep. Yep. Yes, see. Yep, you're exactly right. Told you I'll be forgot, man. I'll be forgot quick. This pump up the hydraulic unit is going to be the single phase, the low voltage hookup for 120. There goes your manual switch right there. And then we got the manual switch here for the high voltage for the 230. And we're going to tie that in and just cut it on, cut it off. It's going to be a simple manual for single phase. When you wire up, when we go a little further in that same chapter, we step up to 3 phase, which involves a transformer, motor starter, push buttons, and all lights. That's a little more involved. It's going to be for 3-phase motors. That's also usually more straight to single phase to this. And we're going to hold the explanation of this until we get through single phase. Just kind of zip through it and make everybody through the single phase, and then we go to 3 phase. Okay. And again, that'll have a little more involved in it. So that would be your next step. From this. The lab sheet includes the 120 and the 230 hookups on single phase. Once you do it and I see it run, I'm going to initiate it. And then you hold on to the paper. Well, actually, you hold on to the paper, and then, well, you might want to let me hold on to the paper because papers can get gone, after class. The 3 phase for low voltage and high voltage, those I'll need to initiate those, and when that's done, then that lab is done. It's complete. So I'll give you the sheet now to begin with. I've got, how many of you are interested in practicing on solder? To solder the resistor?
Yeah.
To desolder. When you desolder, you'll desolder one leg of it to test capacity. You don't have to take both legs off. I got a couple here that don't have any on it, and you'll put a brand new, you put a resistor on there where it doesn't have one. Okay. And You do that, solder on both ends, let me look at it, then you'll unsolder it. So whoever's interested in doing that, raise your hand. Okay, it's a good thing to know how to do. You don't do it all the time. It's not something you would do all the time, every week or anything, but it's a good skill to have. And it takes practice. If you've never practiced, you're not going to be ready whenever that rare time comes up to do it. And also, I want you to test the capacitor with the meter as well. Take a look on Moodle of what I put on here. I put some links on here. Now you see down here, this is on our ELC 117 web page here. You get last night I put in there. Now this is the entire electronic book that I got, that I showed you the other day, that shows the resistor color codes and all. This is a butterball material. I got it separated into some short little pages here. So if you click on resistor color codes, you click there. It only gives you just a couple of pages that you need, 3 pages for resistor color codes. The 3 pages is all that's in there in that link, and you can download it to your phone. So you don't have to search through that book to get them, okay? So you can download that. And then I've got one in there on capacitors. You click it. It's got 3 pages that talks about capacitors. You know that they're measured in farads. They're not measured in ohms, but the unit for capacitance is farads. You know, that's like for voltage, it's volts. For capacitors, the amount of capacitance, capacity to store charge would be in a unit called farads, named after, that was Michael Faraday, I believe was his name. So there's like 3 pages in there giving you just a little intro on capacitors, because that's not included in this chapter. You know, it's not included in the motor control chapter. So
yeah, I got a speaker at the house, and it's got 2 tweeters attached to it, and it's got 2 capacitors on it too. And so I might even look at that and figure out what the ranges and stuff.
It'll be stamped on them more than likely. Should be, and we can test them. This meter will test them.
If you need a meter, they've got cheap but good meters at Home Freight.
What about Tractor Supply? That's the only one that does it.
There's one here in Flint right now.
Do you know if Tractor Supply carries it too?
But I mean, guess what? I think it was like $45. It's got, you can check about everything. Also, you can check heat.
Oh yeah, I might need to go by there when I get check for the rest of the financial aid stuff.
Yeah, I mean,
Does it have farads on it? Does it do capacitor? We'll just show a capacitor symbol. It'll be a straight line and a curved line capacitor. So if you look, this little symbol up here, you know, y'all need to click these links and save them. Right, these are symbols you can see for a capacitor. They're usually a curved line and a straight line, but sometimes it can be 2 straight lines. If the capacitor has, if it's polarized, if it's the kind that has a plus and a minus marked on it, then they will normally have the symbol. The symbol will have a curved line like C2 here. There'll be a curved line and a straight line, and there'll be a polarity marking for plus or minus on the capacitor, showing you that it does matter how you hook it up. Now, if it's an AC capacitor, like for motor start, it's not polarized, because it doesn't matter how you hook it up. It's not polarized. So the non-polarized ones, they can be drawn like this with 2 straight lines that look like a normally open contact, look like a relay contact, and that can be a capacitor symbol for non-polarized, or where it doesn't have a plus and minus terminal. It doesn't matter how it hooks up. If it's an AC capacitor or non-polarized. A variable capacitor, which is rare, has a line through it, which means it's adjustable. And older radios, way back before digital come out, your tuner that would tune your radio station was actually a variable capacitor on some of the older ones. And it was in the tuning circuit that would filter out what frequency came into your radio out of everything in the air. So variable capacitors were used in receivers and transmitters way back before digital come out. So that's a variable symbol there. And again, they are measured in farads. And this meter, when you go to, there are white functions and blue functions in the outer part. If you go to where the horseshoe is for ohms, the second function is a capacitor symbol. And you hit the blue button to get it, to flip it over to the blue function, and it says F for farads. And so that same position, you toggle with the blue button from farads to ohms to check resistance. So with ohms, you can check the actual bleed down resistor, the resistance of it, and then toggle it over to farads and check the capacitance. Just make sure that you see the right unit on the display whenever you do it. Okay. So again, if you have a capacitor that you're in question on one of these single phase motors, you're going to remove the cover like this, and the capacitor is going to have some rubber boots on each end of it. Yeah. Oh yeah. Exactly. Thank you. This is my Zoom cart right here. I'm Wi-Fi and I'm on battery. Yeah. So the capacitor, it comes out of here. Get that shell right there and it comes off. There'll be some rubber boots on it. You take those off and you have to unsolder one of the leads right there of the resistor. Then you can test the capacitor. So again, we went through the unsoldering the other day. Y'all saw me do that. Now to actually test it, you're going to put the meter probes on each terminal on that capacitor and make sure that you don't touch the free end of the resistor. So as you come through and do it, whenever you're up here doing this, it's when you can do the meter part of it. Okay. So kind of as you cycle through, we'll have it set up to where you can, the two of you can be doing this, and I can have somebody else up here. You know, actually we can do, these are going to have to go out there so I can monitor that both of them at the same time with powered up. So people are going to have to cycle through doing this and then going out there wiring these and testing them and all. So we're going to do that for a while. Okay. Go through the single phase with all that. And but doing the testing of it is very, very simple. You can just take the two leads, touch these. Y'all saw me do this the other day, right?
Yeah.
You already seen that. You already seen it. So it just needs to be left up here to where, now leave this one as it is. Let it sit there. And when you go when you go to put the resistor on there, I need to get another one of these.
You said clip it on it.
You can clip this to the lead there and let that hold it while you solder. That's one way to do it. You can run the leads through the hole and bend it back, but then when you go to undo it, it's going to be more to it. Okay, but it's up to you. It's up to you on that part. And you don't have to cut these all the way off just because you're going to be removing it. But you can lay these up there flat. There's something flat like that. You can go down like that. It might be easier. Get that positioned up some. Just move that. solder under there. Let's try that. See.
Yeah, you probably did.
You can do that, or if you want to just run them, that might be best because it's going to be easier getting it off if you do it that way. Actually, that right there would work. You can solder. Solder. Hmm?
Solder from the top right here.
Right, you can do it that way, and it'll sort of run down. It'll sort of run down that way. Just do it one at a time.
Cause I got a tourniquet at the house, like one of these little medical tourniquets that I can probably use for my speakers in my car. And solder them back together.
Alligator clip or anything will work for that. Just something to hold it while you do it.
Yeah.
And the main thing will be this: when you go on there, look, whenever you do solder, it's just like with say with TIG weld, you got to heat the base metal up first, so it'll actually take the solder. So step one would be, you don't want to melt the solder onto it. You want to actually heat the base metal up and then run the solder into it, kind of like this. So you lay it, first of all, go back here and clean it. Clean it good. Get a fresh coat of solder on there, clean it good, make sure it's nice and shiny. There's no contaminants on there like that. Coat it again. You might want to move back a little bit. Can everybody see?
Yeah.
Okay. But look, you can go up here and lay the tip on the base metal like that. And then look, then feed the solder onto the base metal itself, not onto the solder tip. And then you'll see the metal will actually draw the base metal will actually melt the solder for you. You see it melting it?
Mm-hmm.
So the base metal, you're heating the base metal up and then you let it draw the solder to it like that. And that's all there is to it. You come off of it. Don't move it until it cools and hardens. If you move it physically while it's trying to harden, it'll crack. You'll get a cracked solder joint. And it'll be a gray look, a hazy look to it. It won't be shiny. So the way you can know is when you look at the color of it, if it has a hazy look, if it doesn't look shiny, and that looks fine. That's nice and solid, and it's there. Now again, you can run it through one of the holes and loop it around and solder it, but for what we're doing, it's fine to do it that way because desoldering is going to be much easier. If you go through one of the holes and do that, make it mechanically more. If it's going to be permanent, loop it through one of the holes and then solder because it's going to be mechanically stronger. But for what we're doing, just do it that way. And when you go to desolder it, it's going to be less problem. But you get the idea. You see how shiny that is? That's nice and shiny right there. So that's the basic idea. How many of you have had welding down there? Have you done TIG welding? Whenever you get ready to do TIG welding, you got to heat the base metal up first, and then your filler rod, you feed it into to a hot base metal, and then the base metal actually lets it melt, draws it in. So it's the same idea. Make sure your base metal is clean. If it's dirty looking, you want to scrape it clean. They do make little files and stuff, or you can use a little white sandpaper or even a pocket knife to scrape any contaminants off of it. Make sure it's nice and clean whenever you do it. Even the leads of what you're soldering of that resistor, if they're contaminated, scrape them a little bit with a pocket knife and clean them and get all of that surface oxides off before you put it on. So, and then when you go to take it off again, you're going to use the desoldering wick, that stuff there. Let's get some of that cut for over there. Comes in a roll like that, and it's actually literally copper wire that's been braided like people braid hair. It's been braided, so it's actually a wick that draws solder in. Y'all remember me seeing me do this? Did you see that online? Doing the desoldering. Okay, come up here and look real close. When you go to desolder it, this here will actually soak the solder in instead of it making a mess. So you wet the tip again every time before you go to use it. Wet that tip, wipe it again. It seems like you're wasting a lot of solder, but you're not. You're making sure that the tip is not contaminated. So it's nice and clean like that. Put the braid so that you can actually drag it away from the joint. Okay. So you give yourself some slack there, lay the tip on the joint and wiggle like that. When you see it melt, start dragging it. Now it's starting to melt. I pull it and it came off. Now look, you want to get all of it off, look, you do this and you pull and drag, and it'll actually clean the entire surface of that off. And see how it draws it in? It'll draw it in, it'll clean that surface. It'll get contaminants and stuff off, extra solder, just like that. Okay. Yeah. So that's what it looks like when it draws the solder in there. It draws it up like a wick, like in a kerosene lantern. That it draws it up. You know what a kerosene lantern is? You have a wick in there and it draws the oil up to where it can burn. And it has a wicking effect, just like a lantern does. And there goes the resistor right there. I'm just using the same. It's a 100K resistor. We didn't spend much time as far as the color code goes. Take you just a second and go back and look.
Quick question. On his meter, right? We were checking it. It does have the farad.
Yep.
Okay. Yeah, but it says only up to 100 microfarad.
100 microfarad.
Is that about usual? What you need?
Well, they go way bigger than that. They can get up 1,000, 1,500.
What I'm saying is that the main one you use majority of the time for 100 micro?
No. This one here is like 400, but they all have a tolerance to them. They'll give you a range. This one here says between 400 and 480 microfarads.
So they wouldn't be able to test it then on that.
What does it say? 100 microfarads or 100 farads?
100 microfarads.
Okay, so it wouldn't read this one then.
So it'd be the UF is microfarads. Right?
UF is microfarads. And some of these companies put an MF, which they shouldn't do that. M would really be milli, but some of them actually do M for micro, man. And I think it ain't even technically right.
Yeah, we looked at it just now. It says UF.
If it's 100 UF max, then it wouldn't read this one. So it won't read it. It's going to read small ones. Smaller ones, yep. Now they go way down into nanofarads and picofarads. When you look at capacitors, man, they go way down in units. For instance, if you go back and look at the metric prefix sheet that I put in here for you.
Oh yeah, they're going to be great the higher you go.
You see the unit micro would be a millionth of a farad. Nano and pico are used on real little ones that are used on computer boards. So there are capacitors. Look, capacitors on that computer board that'll be down in the nanofarad, small microfarads, and some of them may be in picofarads that are on here, little ones. So yours would read smaller ones that would be more along the lines of something like that there, John. It would read the more on computer level. So you would, if you were going to be doing much of this, you would need to get a meter that's got a wider range to it. Costs a little more. Yeah. Your meter is fine for doing a lot of things. Most people don't have just one meter. They're going to have probably at least two meters.
Yeah, this right here. What's this called?
Actually,
It's a capacitor.
So they're both capacitors?
They just look different. They're just different sizes.
That's a resistor, right?
That's a resistor.
Okay.
That's a resistor, yeah.
All right.
But if you look on the screen about the color code. I know we were in a hurry about that the other day. Color. And to get your color code, look, you go in Moodle right here where it says resistor color codes, and it comes right up to it. You can save it on your phone. It's a PDF. So these are the colors you can have, and most of them have like 4 bands on them. So let's go and look at. I'll go over nice and slow on one of these. Take a look. Ask me if you have any questions about the color code. You would rarely use it, but this is how it goes. And if you ever do need it, at least you'll know how it works. Click that link on Moodle, save it to your phone, and you'll have it. But the resistor that's on here, again, these resistors are bleed down resistors. They bleed down the capacitor when the power goes off. They bleed it down. The capacitor keeps some charge on it like a battery for a while. Unless you put a bleed off resistor on there, it's going to stay charged for a while, and you could possibly get shocked if you touch the lead. So that's the reason for the bleed off resistor. When the power cuts off, it'll go ahead and the resistor will dissipate the charge and to get rid of it as heat dissipation. So that's what the resistor does, is it cycles through and it just kind of goes up like a puff, like a vapor, but you can't see it, but it's heat dissipation, and it gets the charge off of it so it's safe to handle. Okay, so the color code on this one, when you look at the body of it, it has a band here, another band, and then another band. I'm just going to color them in here. And the first band is actually brown. So you have brown for the first color, and then you have black for the second color, and then you have yellow for the third color.
And then gold.
And then you have gold for the fourth color. Now, the way the system works to calculate the total resistance is this. Brown, what does brown represent in numbers?
1.
It's a 1, so you just simply put a 1 down. It's the first significant number. The second significant number is going to be black, which would be a what?
0.
You just simply put a 0 in there. The third number is actually a multiplier. Band number 3 is a multiplier, and it tells you, the color tells you how many zeros to add to the number. It's like multiplying by 10, 100, 1,000, and so on. So the third color is yellow, which is a what? 4. So you put 4 zeros onto this, it's like multiplying by 1,000. Well, actually by 10,000. So 4 more zeros, 1, 2, 3, 4, and put the comma in there, and it's 100,000 ohms. You put the horseshoe symbol in there, or the word ohms. So it's 100,000 ohms is what it'll read on a meter. Now, to shorten that up, what kind of prefix can we use to shorten it up and get rid of some of the zeros? Okay. So if we convert it to K, to kilo, we divide that. We actually get rid of 3 of the zeros and put a K in there. So it's going to be a 100K ohm resistor, 100K ohms. And the K means 3. There's 3 more zeros in there that's not included, and that's what it means. So it's a 100K resistor. That makes sense? So that's how you do the color codes. Now, if you do one that may be let's do one that may be a little more trickier than that. Let's say I have one that had red, Let's say red, red, red. Red, 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 and gold. Oh, and the gold, look, the fourth band is gold, and that's the tolerance. That tells you the tolerance of it. How accurate is it? Tolerance in percent. TOL means tolerance. So if it's gold, gold is what?
5%.
It's the 5%. So look, this number here is a plus or minus 5% accuracy. It's the accuracy of the resistor, which means it could be 5% above or 5% below the nominal value and still be okay. Now you can buy resistors that are 5% and they'll cost you X amount of dollars. If you want to save money, you could go buy a 10% resistor and it could be off more, but it's cheaper. You can actually get them that are more accurate. 2% resistors have a red, the fourth band is red. If you get a 1% resistor, then the tolerance band is brown. That fourth band would be brown for 1%. So military type stuff, military resistors, they're going to get them down into 2 and the 1% that are super accurate for military stuff. And they're more expensive. Or for medical stuff, you know, medical type equipment, it's going to be way tighter tolerance. They're more expensive. So if you go replace one, pay attention to the tolerance band and don't go away from a tolerance. Don't let it get further, you know. So if you had one that said that it was red, 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 and gold, how do you figure that out? Then I'll just stop on this.
Red is 7 on the first one.
No, it's 2.
The 2 or 3?
That's 2.
It's a 2. It's kind of faded out. It goes, look, 0, 1, 2, 3, 4, 5. A 7 is actually violent. It's kind of fuzzy. It's fuzzy. It's just fuzzy. But it would be what? It would be a 2, and then what?
Another 2.
Another 2.
And then 2 zeros.
And then 2 zeros.
Yeah.
2200.
It would be how many?
2200.
2200 ohms. And if I wanted to shorten it to kilo ohms, here's what you do. Watch this real good here. Your decimals right here.
2.2K.
You move the decimal over 3 places. 1, 2, 3, and it becomes 2.2 K ohms, which is the same thing as 2200 ohms. You see that? So that's one to where you got to think about where do you put the decimal at. When you convert to kilo ohms, you got to move the decimal over 1, 2, 3, and then you drop those zeros, and it's 2.2 K. And that's the way that they're actually listed that way when you order them, or when you go to a harvest bin to get them, a tray to get them out of, then they're listed that way, 2.2 K or whatever. So, okay. So let me see what you're doing each time, and let me move this.
I got it on there though. She's tired out.
In case you want to know out, I got to throw those clips.
Too late now. It's already on there.
It's fine. It's fine. We'll slow down.
It's on there. She's done. Oh, back over there. Oh, there's just old.
I was going to get one the other day.
Oh, yeah. I think you agree. My first time, I think it's great. I don't really live, but I do.
You in that corner? I thought you were in there with me.
I got some next one. Let me grab one. Just one second. That way you gotta have something to hold that with.
He knows what he's doing. He really does. And he knows how to repair loaders and all. The guy we're talking about. Yeah, he was in one of our classes last year. And he took over the side. He took over the right. I know you're talking about. He took a lot of,
I mean, Nathan, who's that guy you work with that does electrical?
I'm not 100%.
He works with Schindler's too.
Yeah, he works with him.
He works with Schindler's too. I can't think of his name. Jay Tall.
No, not Dylan.
No, not Dylan.
Works in Schindler?
Yeah.
Yeah, he works with Schindler's too during the day, and then comes out here and teaches the welders.
I mean, it's on there.
He's like over there. I think he does the knowledge.
I want to see your ring. That's what he does.
It's on there.
I've seen another.
Yeah, because he came in class and asked me how the surgery goes.
No, is it alright? Schindler is doing it working off.
And then he said, "Durwood," and said, "Well, I gotta."
But see, the problem with doing the speaker in my car is just like braided copper wire. And so I gotta like re-braid it, solder it together, and then solder the two ends together. And all the time, the fucking wire is like burned. So that's what's gonna make it hard for me.
She's on there.
Here's something here that's pretty cool. It's called Helping Hands. Look here. It's got a magnifying glass, 2 alligator clips. That's not that.
Too late now.
You can move all these around like that. You put your sponge down in there if you want to. You can use that for viewing. So that's, you can rig that up over there for holding that.
Good thing for you.
Oh yeah, too late now, Mr. Right there.
Just use it on the second leg.
Too late.
It's okay.
Doesn't matter.
We got these.
And you may actually like this better, except you, when you use it.
You got to check off on this?
Yeah, let me see. All right. You can just take it loose and we see.
I could have just took out the dots and gave you capacity reading.
It looks good. That's fine. Now, when you think about the boot that's got to go back on there, that boot, you want to have that thing positioned when you solder it so that boot can go on there and it can fit. It can fit within this. You know what I mean? Keep that in mind whenever you do one for real. You know.
I got to take her off. Right?
Yeah, you'll desolder it. Yep. Yep. And that wick, I got plenty of that wick in there. They make the wick in different widths. They make it real narrow and some of it's super wide for doing like big solder joints. So you can buy it in different widths. So I'm gonna on your papers, we'll go in there and we'll add solder. Okay, we'll go in there and add solder in there for a sign off, and I'll sign off on that when I see yours. So did I give you a paper? Did I give you a paper?
I don't think so.
I didn't give everyone. Okay, so let me go ahead and.
How'd you say you take this off then?
Put the wick on there, and then put the solder tip on top of the wick. And then drag the wick. Once it starts melting, then pull the wick away from it. Wiggle the tip, wiggle the solder tip, wiggle it around, and get as much surface contact as you can. And keep wiggling, and the heat will eventually start to melt it, and then you start pulling the wick away from it. And you leave the tip in place, and just it'll draw it. No, it'll do fine. Look, put more of the tip on there, lay it flat. You got to get more surface contact there. Yes, you got to have more surface area contact, and now wiggle and rock that tip. Up top close to where you saw it. Now, when the heat's not transferring, do this. Re-wet the tip. Re-wet the tip. Wipe it off. Cut it again. You got to put a blob on it before you even start. Put a fresh blob on there. The heat will transfer fast, and then it'll begin to. You see how it's doing? But look, the wicket's got to be under the tip. Mm-hmm. You got to just hold your mouth right. You got to bite your tongue. Right. You see it? Right. Exactly. You get the hang of it. See it, but you got to keep the wick under the tip. You tell me, think this has got to stay. Some of the whole stick. Now, it loses suction, push down, and then relock your suction.
Redo this next year, Louise.
Always clean the tip every single time. Put a fresh blob of solder on there, and then you give it fast heat transfer. And then the heat transfer quick. We're going to start that now. Yep. So. Okay.
But that don't even like this.
Now look here. I got you down here for soldering, and then the rest of them as you do them, I'll sign off on them.
All right.
Oh, yeah, I definitely don't want to do it. That's no time. I don't want that.
We'll roll this out there, and we'll roll the other one out there, and we'll get y'all started on wiring them and testing the motors. Okay? We'll cycle everybody through that way.
Yeah, I had to redo this one.
Mm-hmm.
So you got like, you look for
You can do it over and have it clamped until you're satisfied with it. You know, that's something that's not a one-time thing. You know, if you practice it a few times, you know you're going to get better at it as you go. Okay, so let's roll this out there.
Yeah, that's what I'm talking about. That's why I've done that.
If somebody wants to roll this, but don't touch this, because it'll break. This pipe will break real easy. You can push it from down here so it don't break.
Yeah, I kind of figured that out already.
Yeah.
It touched too low.
If you take it further down that way toward that bandsaw down there. That's what we're going to set up just here. You get that one, yeah, everybody else can come on. Whoever's not doing this, and we'll start cycling through. Push it the long way. Yeah, there you go. There you go. There you go. Roll this. Thank
Your turn.
I step over, he cuts it on, and I'm right there on the tree.
Oh my God.
And then I end up about 4 foot in a tree because I jumped that high. I was climbing over the electric fence. My boss didn't know it. He
Sounds
put the
good.
breaker on. Yeah, I felt it.
Very nice. Nice and clean, shiny. You got that shiny look to it. That looks very good. Nice. Had you ever soldered before?
The speaker that's in the back of my truck,
Mm-hmm.
I've soldered it a couple of times, but it's like braided copper wire,
Mhm.
and so that's like really hard, and I ain't got nothing to hold them together. And so I've been using like pliers.
Yep.
And the magnet on the bottom of the speaker, I'll like,
Keeps drawing.
yeah, and I'll like stick the pliers to the magnet and hold them together and try to solder them, but it'll come out like all globby and stuff.
You got to heat the base metal up first.
Yeah.
Or else you're not going to have a good bond. Okay. Well, what you just saw there, you see how that works?
Yeah.
When you heat the base metal up, the solder will actually draw to the metal. Yeah. The metal will draw the solder to it. Yeah. And then you've got a good bond. Okay. You know, you can't put liquid solder and drop it down on cold metal.
Yeah.
It won't bond.
That's where I think I've been messing up at. So that's what I've been doing.
You didn't heat the base metal.
Yeah.
Yeah.
Okay.
And be careful on the speaker. Don't lay it on there too long now.
Yeah, because it'll burn.
Because you'll damage your speaker.
Yeah.
You will.
Because the first time I did it, like so before the gloves like drop it down on the top of the speaker, I was like, oh crap.
Better put you something there to catch it.
Yeah.
Get some aluminum foil or something. Get something to catch it.
Okay.
Get something, something to catch it. And
yeah, I'm gonna try it again when I get home today. Since I learned how to do this now.
Right. Yeah. But number one, surface is clean. Number two, heat your base metal up first, and then let the metal draw the solder to it. And then you'll be good. Yeah. Taekwon, we're moving out. I'm having to move around to the shop where you can see what's going on out here. It's kind of the ideal spot now. The motor, we're going to bolt the motor down to this plate right here. So bring that cart with the two motors on, bring it over here. And also that this. We got to go that way. Over that one. Yep. Sorry about that. Just right over there, be fine. Yep.
It don't matter what, like the high, it got to go to the black.
Normally you put tile on top, but that one.
Okay.
Yeah, we'll get back over here. Hey, John, Eric, roll it over here so we can kind of be the same thing. That's why I make sure the black foot is out. And it's neutral. But in this kind of clothes, it's really going to matter if the white foot is back. I'd rather go specific. All right, Durham, we're ready. We're ready to rock and roll, Durham. We're ready for this. Good. Roll it. Good. Roll it around. Right around the other side over here. We've got to open. And then we'll change it up here. Okay. Who's on home? And when you see if that home, see if that home from actually better. Everybody. And we're going to jump to the barrier and let the income of our private business.
He got shot. You know, they got the things strict.
Yes. We need to get a sheet like we did last year, of when your lap's done. So you can check it off. See if that fit, that's good. It should be. Now, it's down there, we're gonna let the sheet, we're gonna let that down in there. Take something, scratch the print off. So they won't be going to get the print. But if you gotta scratch it up a little bit. If they want to print it, do it. Just gotta get some better shows in there, you know what I mean? There's another metal show in there. There's another show in there. Okay, take care of both of these, and our load is going to make me stack. So you may have, that's your individual. Let's get up a separate. We got a separate one. Let's put this big deal out here. When you do some wire strippers, everybody, you got one side that's for just for solid wire, and another side for stranded. It's for stranded, and that's a number 14. So you got 14 on this side, and it won't bite too hard. It won't cut strings. It won't get through the string. Go into a smaller hole, you end up losing some of your individual strands, and it can overheat. But you want it far enough to go up in the barrel, and to be able to see some of the copper up in here. These crimping devices, you want to crimp them up in here, not in the back. Crimp them up front. And the crimping tool that you use needs to be rated for insulated crimpers. John's got one. Yeah, but it's not a crimping tool. That's a wire. That's a wire stripper. This crimping tool's got a blue dot right in there. You crimp it, and it's for insulated type of nut where it won't crack. There's another. This kind here, and up in here says IMS for insulated and non-insulated down here. This side, you get a dip in that little round area right there. For insulated, if you're going to plain metal, the plastic, you go down there and the non-insulated where that tooth is, and you divide it down on the opposite side, the side of it, the plant. So the barrel comes right in the front. You don't connect anything on the back side. Anyway, for this one, it's insulated, because you use the insulated wire right there, so it doesn't crack. Let some of the copper come out to the front a little bit. Just a little bit. Yeah. We'll make sure that that's fine. Then you want more wires up in here and the other two will be taken from the wire. This needs to be cut back further so somebody can go through this. But the barrel is going to go in here, there. All right, 5 wires. Okay. We'll take up on this is a 4-day week class. It's shorter than the 4 days. Every time so we'll do it line Thursday. We're going to go over what happened to the whole thing. Well, this is high. This is going to be about 230. The low is here. The low is high. That's fine. That's good. Good. Can I see it on monitor? Yeah.
Yeah, just get your, yeah. Check your current one, and you want to get the hot wire. The hot wire coming in, and you'll get around that. Start up fast. Hang on, around 8 point something. Start up fast. 115 volts, 8.6 amps. 330 volts. 8.6 is what amps is going to be at the top. The start signal is going to be about 35 amps. Actually, listen, Kenny, you got to have on the glove too. You got to have on all this. There we go. Taquan, sorry about the. Taquan, if you're listening out there, you're going to wire this up. This motor right here, you'll wire it up on 120 volts. And they've already done that. We're going to test the motor right now.
Explain the safety use.
Yeah, he's putting on his electrical gloves, face shield, the arc flash coat. And now we're going to measure something called inrush current. And let me get the camera over there where that can be seen too. So let's get the camera where it can be seen.
37.
7.9 amps. That's your running amps, okay? Now, if you cut it off, let's do it one more time. If you notice, the motor is going clockwise, isn't it? And we're also going to let you flip it around and see it go the other way. We'll watch that inrush one more time. You heard the switch. That was the centrifugal switch in here that actually reclosed when it slowed down. Go ahead one more time. What was it? 36 amps, about 37 amps, and then it leveled off to about 7.7, right? So that's something called inrush. Inrush current, and that has to be accounted for. And when we get further in our chapter in the book, we're gonna be talking about how do you make plans for that. you got to do some calculations now. So our next step is, if you want to, we go hit flip it, run the other way. Let's do that. See, parking up, yeah.
Let's get somebody walking through here.
So now, he's going to make the motor go counterclockwise, and he's going to do it by following instructions that are on the paper that I gave y'all. Now, another caution would be this: is you might want to. I would put that on the floor like that. Hey, I would put that up here so we don't end up breaking it and get tripping on. Yeah, you could those things. Yeah. Right. So he's going to rebundle. He's going to rebundle the black and the red in here, which is actually the start winding. If you look at the diagram, the start winding. Yeah, the internal diagram I gave y'all that shows the internal parts. It shows where you can tell that it's actually the start winding that we're reversing. Now, one thing that you have to do, this pump ain't going to like that. The pump only wants to go this way. If you notice on the casing, on the front casing right here, it's got an arrow going to the right. See it? You can only run it to the right. It won't pump backwards. Right. It's not a gear pump. Some gear pumps can go two ways. That's a centrifugal pump. So we're going to slip the belt off of it. We're going to loosen it here. We're going to get the belt off so it doesn't run the pump dry. Mm-hmm. Yeah. Well, you can. You're going to be flipping your T5 and T8 leads here, or it's actually T10 on that motor. It's actually 10, 8 and 10, isn't it?
On here it says connection shows are for CCW, which is counterclockwise unit, lead into the motor. The clockwise rotation interchanges black for J10 and red for T8.
It's T8, T10, but here on this paper it's T8 and T5. But basically you're flipping your start winding. The start winding itself is in series with that switch to your quick. So what he's doing right now is he's reversing the outside leads for the start winding. He's reversing these outside two, and it will make the motor kick off and go the other way. See here, that pump only wants to go clockwise. See the arrow on the pump casing? It's only going to pump one way, and it'll run dry. It's the pump won't be happy. No, you just loosen that red rod right there. Loosen it. It'll move it. The whole motor moves like that. Just take it off like that. You can just let the belt kind of hang over that. They find it.
I got a question.
Mm-hmm.
Since we're staying in here for next class and he's not here, can we use that board to put his Zoom class on?
Yes.
So we ain't all staring at one individual computer.
Yeah. If you want to, yeah, we'll do that. Yeah.
That area broke out their computer, but it probably wouldn't see.
Are you still doing the current class?
No, we're just all here.
Oh, yeah.
So is he going to be teaching? Where's he teaching from? Home. Yeah. I've done it many times. So this time you're going. So this time you have red, white, yellow, and one lane, right?
Red, white, and yellow.
Black, white, black, blue, and orange.
Blue, orange, and black. So now it's going to go this way. So this time you should see it go counterclockwise instead of clockwise. What you can do is, you know, you can just bump it on easy, bump and then cut it right back off, and cut it off. See, it's going that way now. Go ahead and let it run. Now, cut it off and let's listen to it. You'll hear that centrifugal switch reclose. But it takes a while because it's free wheel. It ain't got no, there ain't no inertia there now. It's just, there's no load. There's no load. So you might want to ask, well, why would I ever want to reverse it? Well, okay, several reasons. You may have a fan situation that you may have an intake fan or an exhaust fan in a hog house or in a roof, and that motor has to be able to draw something in or let something out. It can be running a conveyor. It can be running an auger to bring feed in, and that auger might be running this way or it may be running that way. So all your motors have to be able to go in two different directions. Some pumps want to go clockwise, some want to go counterclockwise. You got to go in the pump casing and find out what that is. You know, if you look on this side, you see that arrow right there? The pump is telling you to go clockwise. That arrow wants to go clockwise. See it? You take the pump off. Yeah, but every pump has got, if you get onto a gear pump, now some gear pumps are bidirectional. Some pumps are bidirectional, like gear pumps, and but the centrifugals are one direction. They ain't gonna pump with just one direction because of the way the impeller is designed. The impeller is only gonna swing it when you go you're quick. Yeah, I'm not messing. But there's a spring there's a set of springs back in here, and it actually pulls against this switch, and it has to overcome the centrifugal force has to be high enough, which is like 75% of your nameplate RPM, before it can actually swing it loose. It's kind of like when the astronauts go out, they get out so far and then they escape the gravitational pull of the Earth. It's basically kind of like that. You got to overcome the pull of the springs, and then it swings it open, and when it does, it swings out of it. Yeah, so it doesn't need the capacitor no more, so it pops out open there. Yeah. It gives it an up to get started. That's why I remember specifically seeing a guy come to work on the air conditioner at the house years ago. He'd be out there and he would be testing it, and the fan would go and it wouldn't turn. And so he would check, he would. I've actually seen him flip the fan with a screwdriver, and they flip it and then cut it on. It go ahead and run.
Like on the airplane.
Yeah.
You know, some of the small airplanes.
Mm-hmm.
You got to go first.
Mm-hmm. Right. There you go. Right. So you hold on to that. Well, again, it takes a little bit of time to cycle through it that way, but
It's fine with me.
Yeah.
This is simple right now.
And if you want to wire, you actually got a class start now, right? Yeah. You want to go in there and get the Zoom hooked up? Yeah. That's fine. Mm-hmm. Let me get out of what I'm in. Let me get logged out of Google and all that stuff, and so I don't have all that still on. Mm-hmm. Yeah, and it's going to be that's going to be on the high voltage on the 230. So everybody will wire that one also. All right, Quan, sorry about all the moving around, buddy. I'm going to end the session, Quan. I'm going to end the recording, let it go ahead and process. Hope to see you tomorrow.